So I can create pipe here if I wanted to isolate this area here. Maybe I want to isolate this area here. And there's another pipe right here. There's another pipe here. So from this view, you can even create pipe. So let's say I want to build a center line here of this pipe. I can just invoke the command, click on the pipe, and it'll place the center line. There you go. There's your center line for that pipe there. So you can pretty much follow a line all the way down here, as far as it'll go, and then go ahead and create your piping center lines. Okay. And then if you want to go ahead and see the whole view again, you just click Turn Off Limit Box, and then you see the same view as in TrueView. So this is a great way to view your point cloud and to see what's going on. You can also change the rendering inside of the TrueView. You can change it to grayscale like you have in the main scene, so the scenes look exactly the same. And again, no matter what you do here, it's copied over there. Okay. You can see here, as I continue rotating around, it copies your view. And that covers the TrueSpace and the key plan part of the exercise. Okay, so let me. You can also change the rendering in the main area by hitting this button here and going. Maybe you want multi-hue. Okay, you can, and then you go to a multi-hue view. Some people like this because it's brighter. If I go up to like maybe this section here, you can see here that it really shows out quite well. So it's really easy for you to pick out these pipe runs and create all these center lines and then connect them. And you're creating actual PDS elements here, graphical elements, that you can then assign more intelligence to later on. You can also lower the density of the point cloud. You can pick, so it's easier to render, but it just shows less points. So you can lower that down here, point density all the way to 4 or 1. So you can see the reading point blocks when I picked 1, because it's going to be at the highest level. It's going to crank it up, so it's going to fill in the space up here as you see. Got filled in. Okay. I'm going to shut this down here. And then you can go ahead and go back into top view if you want to, and it goes back into the top view. You can also pick on the point cloud here and just get a query. You can also get point cloud information here. When you pick on the point cloud, it'll show you how many points you have displayed, and then what the intensity is, and so forth. It'll actually show your pick position, where you've picked. That's the XYZ position of where you picked, the intensity at the pick there. And then this is the amount of points that you have in the whole point cloud. And this is the intensity ranges. Okay. I encourage you to use your regenerate point clouds if the density gets low. And also, I'm going to just want to quickly show you that to open a TrueSpace again, you can click this toolbar, click on the point cloud, and again your TrueSpace will open up. And then after you turn it a couple times, sometimes you have to get it in perspective view. There you go. Yeah, there you go. So if it doesn't sync right away, change your view in SmartPlant, and then it'll properly align and it'll properly densify. Again, if it's low in density, just go ahead and click this here. It'll read the point blocks again, and then it'll refresh your view, because you're loading in actually a lot of points in the viewer and in the other the TrueSpace. And there is the refresh showing all the points. Please make sure to let us know about your recommendations, additions, or tools. Please make sure to check out the documentation on the next part of the workflow you see, which is Flange Workpoint. This is great to get the connection points. There's a database that I'm going to have you load up and do a few work point functions on. And please follow the documentation and let us know how valuable that is to you. Working with the flange workpoint tool in SmartPlant 3D. Go ahead and open your data set. I have one preset here, ESS file. In the model space view dialog, this is a dialog from Leica. Go ahead and click on the small box, and then browse to a database that you have previously added in an earlier section. We're going to go to inline flange here, and we're going to say open, and then we're going to go ahead and say OK. This is going to go ahead and load in the point cloud here, and then go ahead and set your view. Now, I had to previously set my view using a couple different methods because I didn't fully understand how this worked. But here we go. And let me set. Okay. So you can get this point cloud in the view if you know more about SmartPlant 3D. However, this just covers the main part of the flange workpoint process. Okay, so the flange workpoint tool. So with a point cloud isolated, either by clipping planes or by limit boxes or some other process, you can start to get the flange workpoint. So we want the flange workpoint is the center in between two flanges and where the gasket is. It's an imaginary point. So to invoke the tool, you can either use the icon on the desktop here, or go ahead and in the toolbar, or go ahead and go to Fit Point Cloud Flange Workpoint. So there's several methods. I'm not going to be going over every single one of them. There is, however, documentation provided with this package that goes through everything. So in the neighbor process, your first step is basically fit a cylinder. So that's the first pick. So pick on the cylinder that comes up to the flange, either above or below. So what it does is sets a temporary center line here. Okay, so that's your first pick. Your second pick is going to be right on the back of the flange here, right? And then you set your offset. Okay, so I'm going to set my offset at 0.059 because that's the thickness of the flange. So you know the thickness of the flange you're working with. You can just enter it there and say create flange. So after you create it, you see this graphic here. This graphic is the center point here is this imaginary tie point, which is what you want in between the two flanges. So that's using neighbor. So I'm going to go ahead and close this and then delete this graphic here, so we can then try some of the other processes. So the other way, I'm going to go ahead and use the toolbar to invoke the command now, is you can use one of the directions, the cardinal directions, to then make assumptions about which way is up, basically. You can use northing, easting, or up. So it depends on the coordinate system that you're set in. Okay, so I know that this is set to where north is up here. Okay, now once you've got your directions set, you need to make your first pick. Okay, and your first pick is going to be in the center here area of the flange. So you pick here, and it's going to create a temporary flange. Okay, you want to make sure that's correct. If it's not correct, press reset, and then just go ahead and click here again. And again, it's going to calculate another temporary flange. The next pick is going to be the back point, the back of the flange. Okay. And then you're going to go ahead and want to set your offset distance. I happen to know it's 0.059 for this flange. then I say create flange. Now you can see here that it was the negative distance. It depends which way your direction is going. So I'm going to go ahead and then reset, and then I can go ahead, I can delete these afterwards, but let me go ahead and just reset again and have the tool recreate the flange. And then I'll pick the back of the flange here, and then I'm going to put negative 0.059. So, and then you say create flange. Now you can see that I've got the flange point right where I want it, right in the center there. So there's a couple different ways to make it. Now northing is, I've got the Y going up the screen, that's why northing worked. If X is up the screen, then you pick X or up, or easting X, northing Y, or up north. So there's a couple different ways to create this. If you have a lot more points, or a great deal of saturated points, you can use 2 or 3 point picks. These are the least accurate, and they actually try to region grow this flange in here. So I'm not going to be going over those, but you go ahead and look at the documentation. The one I've showed you, neighbor, is by far the most accurate because it creates a center line off a nice straight pipe, and then you pick the back of the flange and enters the offset. So that is flange work point, showing you the neighbor method and the cardinal direction methods here. And these also work the same way, view X and Y.